So this is sliding window XOR. You are given an array of n integer. Your task is to calculate the bitwise XOR of each window of k elements from left to right. In this problem, the input data is large and it is created using a generator. Okay, and we are given n number of element size of window, 4 integer x, a, b, c, the input generator parameters, and this is how our input is generated. So if we read the input, so n is 8, so we have to generate 8 elements and k is 5, that is our window size. Then we are given 4 element x, a, b and c. Okay, so what is our x1? So since we have to generate from x1 to x8, right, that is x, that is 3. What is our x2? That is ax1 plus b, right, that is x2 is equals to ax2 minus 1 is 1 plus b mod c, so that would be 7, a7, x1 is 3, that we calculated here, then b is 1 mod 11, that would be 0. Similar fashion you can calculate x2, x3 and so on. Okay, and this is what you will got. Okay, so this is just a calculation part to generate the numbers while we are iterating all that. So this is one more way. Let's say if somebody doesn't want a factor and it's a sequence, right, so he can just use the generator anytime. So he is actually saving the space, right, from storing the element. So this is actually a space saving method, one of them. So the windows, then we have to figure out all the windows of 5 size, like 1, 2, 3, from 8 this is 4, and for each window we have to calculate the XOR of each window of k elements, right. Then we have to calculate XOR of all elements in that window, and then we have to XOR all the elements. Okay, so now just understand the concept of XOR. Okay, so if we do A's or B, we'll get something, right. If we do C's or D, we'll get something. Let's say we are doing XOR of this two. Okay, so what exactly would be this thing? This would be A's or B's or C's or D. Okay, so the thing is, it's not mattering if we are XORing A with B first or A with C first, right. So at the end of the day is, okay, if A is there, if A is XORed 5 times, then we have to do A's or A's or A's or A 5 times, and then B as many as times it is there, right. So this is the one associative property, right, of the XOR. Okay, so this is one thing, and one more thing is, let's say if element is XOR with himself, it will get 0. Okay, and if an element is XOR with 0, it will get himself. Okay, so we will use this concept. So if there is even number of occurrence of A, then it would be 0. If there is odd number of occurrence of A, it would be A, right. So XOR would be so within that XOR actually, so we have to take either that element as 0 or that element itself while we are doing XOR. Okay, so the task is to calculate how many times or in how many windows that element is occurring, right. Okay, so let's say this is our input element, so 3 will occur only in first window. Okay, so that would be 1 time, so this is odd, so we will take 3. 0 will occur in first window, second window. Okay, so it is occurring twice, so we will, since it is 0, we are taking 0 anyway, right. We are taking this 0, but okay, A is itself 0, so don't get confused with it. That 1 is occurring three times in the window, like in this window, in this window, in this window, right. So we are taking it as odd times, right, so we will take the element. Then 8 is occurring 4 times. Okay, all 4 windows, so we will take 0 in place of that. So we are doing XOR of these elements like this, we will keep on doing, right. So at the end what we are getting is, that would be the answer. So in this case it's end up doing to 0. Okay, so what here it is explained, it is brute force, like somebody is iterating over each window, and then within that window he is calculating the XOR of each window, and then he is actually XOR of doing that XOR. So this is the optimized things that we are using the concept of XOR. One is the associative property and one is the identity property, right? Because what XOR saves as identity when it is done with itself, right? Or 0. So now we will see how we'll code it. Okay, so we are taking the input here. Okay, so this is the line, it is input. Then what we are doing is we are calculating how many times that element is included in the window. Mod 2 is, it will tell us it's even times or odd times, that number of occurrences, right? If it is odd, then we are including that in XOR. Otherwise that element, if we are not including, that means it's 0, right? If we are doing any XOR with 0, it's element itself, so we are not doing anything in that place, and we are generating at the third step x, right? Now how we are calculating what is this thing is that is minimum of I plus 1 comma n minus I, right? So this is actually we are trying to calculate how many times the number is included, right? So the first number, right, would, let's say the size is 3, so it will be there in 1, right? That is 0 plus 1, that is 1, n minus I is that would be 5 minus 0 in this case, that would be 5, so that would be 1 occurrence, right? So why we are doing this thing is, let's say if element exists here, right? Now the thing is, if the window size is 1, okay, then this is window itself starting from here. Okay, if window size is 2, the window cannot start from here, right? If window size is 2, the last window will end up here, right? So it cannot get included in more than one window in that case, because window size is 2, then last window would be here, right? Because if window will cannot start from here, right? Because there is no element here after that. So that's what n minus I says. N minus I says that the last window, right, that is what this, let's say we are with this index, this is 5, this is 4, this is 3, right? So 5 is the actually size, so this would be indexed as 4, this is indexed as 3, right? So we will get as like that, 5 minus 3, right? So this, how many times it gets included. So that's what we are doing, right? And since the element cannot exceed in more than k windows, right? Let's say I am at this place, right? So it can cover this one window, this two window, and the at max, right, two times, right? So because the windows will keep on sliding, so at max we are including element is the window size. Okay, so that's what we did, minimum of k here. Okay, so that needs to be keep in mind, because that is one of the edge case for the center elements, and n minus I is the edge case for the subsequently last element. Okay, so if let's say what is n minus I is, let's say n is 5, I is 0, 1, 2, 3, 4, 4. If we reach at 4, so 5 minus 4 is 1. So this element is included only in one window. Okay, at max it can be included in one window, because there is no element beyond that, so window will not slide beyond this. So this is where the windows will end. So that is something that is edge case for the this thing. Okay, now we will execute this code. Okay, so we will go execute. So our input was 8, 5, 3 was our x, b was our 7, a was 7, b was 1, and c was 11. So if we execute, you should get a 0. Okay, so this was the sliding window. So